All right, so let's have a look at some common covalent compounds so we can work on names and symbols for them. So several compounds were known long before we knew what their elements were, and so we still use those common names. So water. Well, water, all of you guys already know, is H2O. Ammonia is NH3. Methane, CH4. Hydrogen peroxide, you've got this at home. You use it for cleaning cuts. H2O2. Hydrogen sulfide, H2S. Naming system for it is just like an ionic compound, but it happens to be covalent. Silicon carbide, those really hard drill bits and sawtooth blades, silicon carbide, SiC, silicon carbide. And ozone, the gas O3. Okay, so those are the common ones. So now let's have a look at the standard system. It requires the compounds use prefixes, and prefixes are a little piece that comes at the start of a word, just like a suffix comes at the end of the word. And that prefix is going to tell us how many atoms a particular compound has in it. So the prefix mono refers to 1. Prefix di refers to 2. And we're going to get the idea that these are going to come in order. So 3 for tri. Tetra is 4. Penta is 5. Hexa is 6. Hepta is 7. And octa is 8. That should have been an A. Octa. Okay, so those are the common compounds and the prefixes we're going to be using. So, covalent symbols to names, symbols to names. So, first step is write the name of the first element, and if there's more than one of them, we've got to use the correct prefix. And then the second step is using a prefix, which means the second one always is supposed to have a prefix. Write the name of the second element with the IDE ending, just like we did with ionic compounds. So, example 1 is CS2. So, write the name of the first element, and there's only one of them, so it's just carbon. Number 2, using a prefix. Well, subscript here is 2. That means di. And then write the name of the second element with the ending IDE. Sulfide. Carbon disulfide. Okay, N2O5. So write the name of the first element if more than, gotta change that. 1, should have read that earlier. Use a prefix. So 2 for the nitrogen, di-nitrogen. So first one has more than 1, so it gets prefix, di-nitrogen. 5 is pent, oxide, dinitrogen pentoxide, N2O5. And the last one of these, XeF6, xenon, no prefix because there's only one of them. 6 is hexafluoride. Okay, so the first one only gets prefix if there's more than one of them, and the second one always gets prefix. And the ending changes to ID. So that's converting symbols into names. So let's go the other way. To convert names to symbols, first step, write the first element symbol if there's a prefix recorded as a subscript after the element. Number 2, write the, second, I got to pay more attention. Write the second element symbol and record its prefix as a subscript after the element. So, sulfur dioxide. Write the first element symbol, S. If it has a prefix, doesn't apply. Write the second element symbol, O, and record its prefix as a subscript after the symbol. Well, that di becomes 2, and it goes after the element symbol. So sulfur dioxide, SO2. Phosphorus pentabromide. First element symbol is phosphorus, is P. Bromine is Br. And penta is 5. Next, dinitrogen tetroxide. So nitrogen, prefix di for 2. Tetraoxide, so oxygen for oxide, tetra is 4. Tetra is 4. Now, if this were an ionic compound, we'd be looking at those subscripts and saying, oh, 2 and 4, I can simplify that. But with covalent compounds, those prefixes tell you exactly how many there are. You never simplify. So ionic you simplify, covalent you do not. The prefixes tell you exactly the number. Thank you.